Hello friends, this is the last theory part of our chapter, that is Lambda expressions. Okay, so we will start now. Method references with generics. Okay, you can use method references with generic classes or generic methods. What are method references? We have to just refer a method and we are not calling it. For example, consider the following program. Now we will demonstrate a method reference in this example to a generic method declared inside a non-generic class. Okay. What is that? Method reference. Okay. So we have already understood the method reference in the previous session, and we will use it to a generic method reference to a generic method inside a non-generic class. So interface declared, which is generic, functional interface that operates on array and value and return and result. Okay, return an integer result. This class defines a method called count matching that returns the number of items in an array that are equal to a specified value. The count matching is generic, but the my array OPS is not. Okay, so my function interface is a functional interface. It has only one method which is having no body. Integer function have two parameters. One is array and second is value. And what this function do? This method is called count matching. Okay, this class defines a method called count matching that returns the number of items in an array that are equal to specified value. If suppose I am passing a particular value 5, so how many times 5 are appearing in that array? If I am specifying 7, how many times 7 are appearing in this array? Okay, so count matching is a generic method, but my array OPS is not. So my array OPS is a class name which is not generic, and count matching is a generic method which is a static method. Okay, so here we are passing type array and type value. Okay, so from I0 to val's length, like array length, what we are doing, if any particular value of that array is equal to the value specified. Okay, like 5 is coming 3 times in the array, so count will be +1 +1 +1 3 times, and it will be returning your count. If 7 is specified, if my value array is having 7 2 times, and I am passing to find out how many times 7 is there in that particular array. So what will be the count? It will be incrementing the count variable 2 times. Okay, so generic method reference demo. In that, this method has a my function functional interface as the type of its first parameter. Okay, the other two parameters receive an array and a value, both of type t. Okay, so my function functional interface as the type of its first parameter. So my OP is a generic method, and its first value will be the reference variable of the my function functional interface. Okay, that is the first parameter of this method. And the second two parameters are array and the value, both of type particular t. And what will we be doing here? F dot function. What is the function? Function is my functional interface only function, which is a abstract function. Okay, and here we are passing values and b. Okay, in the main method we will be evaluating it like this. We are passing the method reference to a generic method. Count matching is a generic method. Okay, count matching is a generic method in that. So how we are calling it? My array OPS here, which is a non-generic class, double colon integer count matching. So count matching is returning what? Integer. Okay, so type is integer, and next value is the array. So how many values are there? 1 2 3 4 2 3 4 4 and 5. and which value I have to find out here is 4. Okay, so 4 will be passed to this array. Okay, and find out how many times 4 is coming. And what is the method definition? This is the method definition, count matching. So my array OPS class is having generic method. Integer is a type, like it is a generic method, and the method name is count matching, and we want to find out how many times 4 is appearing in this value when we are calling the public static void main. Here we are passing the actual values or actual variables on which we have to operate. Okay, and then values contains count plus 4s. Okay, so how many times 4s are coming, that count will be displayed as the output. Next, second array is string array. Okay, why we are using it as generic? We can here use any number of any type of primitive type. Okay, here we can pass float. Here we can pass double, boolean, etc., etc. So here we are passing the second array, that is string array, and in this string array we want to find out how many times 2 is appearing. So here 2 is appearing 2 times, here 1 time, and here 2 times. So output will be 2 times. Okay, values array contains 3 4s and string array contains 2 2s. Okay, so this is the output of this program. My array OPS is a non-generic class that contains a generic method called count matching. Okay, so my array OPS is a non-generic class. It is having no type definition that contains a generic method inside it. It is called as count matching that we have seen. The method returns count, okay, as the integer count of the elements in an array. Okay, so return type is always integer as a count, but array we can pass. So return type will always be int. Return type is not t. Return type is int. But the array type is this we are passing, and array value type that we will be passing to find out in the array will be t. So here if we are passing the array as string array, so we will be finding out string value in that particular array. Okay, so when we are calling that method reference to a generic method, okay, method references with generic classes and generic methods, we will be passing the type. Okay, so if value is boolean, type will be always boolean. If values array is float, this will be always float. So we cannot find a string value in the boolean, right? So this type, and this type must be the same, and for that purpose what we have done, we have declared this count matching method as the generic method, so that we can replace this t number of as many type of parameter as we want. Okay, next, how generic type argument is specified. Okay, so integer in the main function, this is the static method. Okay, so since it is a static method, we are calling it without using the object. So this is the method called myOp. This is the method called count matching, and myOp is also a generic method, static t integer myOp. Okay, so this is also generic method. This is also not needed object name. This is also not needed an object name, only a class name, double colon, type specification, and then method name. Okay, passes the type argument integer. Notice that it occurs after the double colon. The syntax, this syntax can be generalized. What we have to do, we have to first give the class name, okay, and then type argument comes after the double colon and before the method name. So we will tell the compiler which type of value we want to find out in that type of particular array. So we will be passing it as a generalized syntax. The explicitly specifying the type argument is not required in this situation. Okay, so when we are explicitly specifying the type argument, It's not required in this situation because it will be automatically inferred. Okay. In which the cases in which a generic class is specified, the type argument follows the class name and it's the double holder. Okay. The cases in which generic class is specified. Okay, generic class. This in this example, the class was not generic. The type argument follows the class name and type argument follows the class name and then type and then double colon. Okay. The preceding examples show the mechanics of using method references. They will not show their real benefits. Okay. One place these method references we are using can be useful is in conjunction with the collection framework we have already seen in the previous chapter. Okay. But for completeness, in a short but effective example that uses a method reference to help determine the largest element in the collection is included here. So we will now be watching the real example. Okay. So real world example that will be giving us a real benefit of the method reference. Okay. If you have already done collection framework, so no need to worry about it. If you have not did it, just go back and complete the collection framework class. And after that, we will be understanding it. Okay. One way to find the largest element in a collection is to use the max method as defined by the collection class. For the version of max used here, you must pass a reference to the collection and an instance of an object that implements the comparator interface. Okay. So what is the way to find the largest element in any collection? Use the max method already defined. Okay. So here we have used the specific version of max method. For that, you must pass a reference to a collection and instance of an object that implements the comparator interface. Okay. So this interface specifies how two objects are compared. Only one abstract method called compare that takes two arguments, each the type of object being compared. Okay. So we are calling the abstract method called compare from the comparator interface. What it will do, it will take first of all two arguments and each the type of objects being compared. Okay. It must return greater than 0 if first argument is greater than the second, 0 if two are equal, and less if the first is less than the second. Okay. In the previous examples, to use max with user defined objects, an instance of comparator T had to be obtained by the first explicitly implementing it by class. Okay. So in the collection framework class chapter that we have understood previously, what we had to do, to use a max method with user defined objects. An instance of the comparator interface had to be obtained by first explicitly implementing it by a class. So first we had to implement the comparator interface by any particular class, and then we was able to use maximum method with a user defined object. So first we had to declare a class that implements the comparator interface and then use the max method with the user defined objects, and then creating instance of that particular class to compare two objects. The instance was then passed as a comparator to max. Okay. Now, beginning with Java 8, it is now possible to simply pass a reference to a comparison method to max. Okay, because doing so automatically implements the comparator. So all things are being easy for now. What we have to do after Java 8, it is now possible to simply pass a reference to a comparison method. Okay, comparison method's reference to max method, and after that automatically it will be implementing the comparator interface. So you no need to create a particular class that implements the comparator interface and then use the max with the user defined objects, and after that we would have been creating instance of that particular class. But nowadays, what we will do, we will pass a reference to a comparison method to max, because doing so automatically implement a comparator interface. Now we will see some simple example that shows the process by creating an array list of my class, okay, my class objects, and then find the one in the list that has the highest value as defined by the comparison method. Okay, so now what we will do, we will create the array list of my class objects. So there is one class called my class, and we will be creating array list of all the class objects. So that array list will be having objects of type my class, and then finding out the one in the list which is having the highest possible value. The user method reference to help find the maximum value in a collection. For collection, we have to import java.util. Okay, then we are creating my class. In that, we are declaring a variable called val, which is private and which is integer. So parameterized constructor v will be initialized like this, value is equal to v. Then get value will be returning get value, returning value. Okay, so now next class is use method reference, a compare method compatible with one defined by the comparator t. So we are declaring the method compare now, static integer compare mc, my class a, my class b. So this compare method should be compatible with the comparator t interface. Okay, return a dot get value minus b dot get value. So here we are passing two values, two class objects. Okay, both objects are representing the same class, my class. Okay, so what we are doing, we are comparing these two objects of the same class. First is my class object A, second is my class object B, and what we are returning a dot get value, a dot get value minus b dot get value. Okay, so in the main method we are creating array list of objects of class my class. Okay, and we are adding the values now, like in the parameterized constructor. This is the parameterized constructor of my class. 1, 2, 3, 4. 1, 2, 3, 4. Sorry, 1, 4, 2, 9, 3, 7. Okay. So find the maximum value in array list AL using the compare MC method. So what we have to do, we will first create the object of class my class, maximum value object is equal to collections.max AL. So first will be the collection, and second is use method reference colon compare MC. So use method reference is a class. Okay, then double colon, and which is the method we want to call it. This is the static method. For static method, how to call the method reference, how to pass it, using class name double colon method name. So since it is a static method, this is the class name, use method reference double colon, and this is the method name we want to call, and on which we have to operate on this array list AL. Okay, and this in this array list there are elements 1, 4, 2, 9, 3, 7. Okay, so maximum value will be 9. Okay, so in this a dot get value minus b dot get value. Okay, so every time we are getting finding out the maximum in the past objects. Notice that my class neither defines any comparison method of its own, nor does it implement the comparator interface. These two things are very important. The maximum value of a list of my class can still be found out or obtained by calling the max, because use method defines a static method compare MC, which is compatible with the compare method defined by the comparator interface. So there is no need to explicitly implement and create instance of the comparator interface. So we can directly use it. So this class use method reference is directly obtaining the objects of my class A and my class B, two objects of the same class, and then finding out the comparing the two objects. Okay, so no, there are two things we are eliminating. First is no need to write down the method, comparison method, and second is no need to implement the comparator interface. Next, constructor references. Similar to the way that you can create reference to methods, you can also create reference to constructors. Here is a general form of the syntax that we will use: class name colon new. Instead of class name double colon method name, we are directly using class name double colon new. Okay, this reference can be assigned to any functional interface reference that defines a method compatible with the constructor. Okay, so any particular functional interface reference, any particular functional interface that is creating a similar method. Compatible means similar method, same structure, same return type, same number of parameters, same sequence of parameters, same type of parameters. That is called as compatible method. Same to same method if any functional interface declaring same to same method as that of the constructor. So in that case, you can use this reference class name double colon new to that particular functional interface. Now we will see the example of that, demonstrate the constructor reference. Okay, my function is a functional interface whose method returns a my class reference. Okay, interface my function and my class function integer a. So in the my class, this constructor there is one variable called value, and this constructor takes an argument. Similarly, this is a my class, then function and integer a. So same structure here. Here is also it is having one parameter n returning my class, one parameter b returning that is the object of the class. It is object of the class my class, and it is also creating object of the class my class, and initialized to value is equal to b. So it will be directly related to this functional interface. So this is the default constructor. This does not matches. This is the get value method. So create a reference to the my class constructor. Okay, my class constructor reference, because function in the my function functional interface takes an argument that is n. New refers to the parameterized constructor in my class having the not the default constructor. Okay, so new will be creating a calling the parameterized constructor. Why? Because function in the functional interface having one argument. Here it is having one argument, and here it is also having one argument. Here this is having no argument, so this does not matches with this. This matches directly with this constructor. Okay, so my function my class constructor is equal to my class double colon new. Now, so this reference, this is the constructor reference. Okay, my class constructor is a constructor reference, and how it is created? My class double colon new. Okay, it is create a reference to the my class constructor. Now create an instance of a my class. Create an object of the my class via the constructor reference. So this is the constructor reference dot function in the bracket 100, and this will be creating the object of the my class MC. Why creating instance? Because here also this is creating object. What is object when we are creating any constructor? Sorry, when we are creating any object. Okay, so default constructor or parameterized of constructor will be called automatically, that we have already seen while we have learned Java. Okay, and this is also creating the returning the object of my class. So both ways it is creating the object. Okay, so indirectly what we are doing, we are creating an object of a my class. Instance means object of a my class, via that particular constructor reference. So this is referring to which constructor? Parameterized constructor, integer v. Okay, so 100. Okay, so now we have related to that parameterized constructor, and what we have to do in that? We have to just initialize value is equal to v. Okay, and in get value we will be returning this value. So what we have to just get that value and display that value, as simple as that. Use the instance of my class just created. Value in my class is equal to mc dot get value, and output is value in mc is 100. Okay, if you have not understood, you can go back and revise. In the program, notice that function method of my function returns a reference of my type my class and has an integer parameter. Okay, this is the functional interface name my function. Function is the name of a method. Returns a reference of type my class, that is object of my class, and has an integer parameter. Notice that my class defines two constructors. Okay, first is having parameter and second is having no parameter. So my function my class constructor creates the constructor reference is equal to my class double colon new. Okay, so the expression my class double colon new creates a constructor reference to a my class constructor. In this case, because my function method takes an integer parameter, the constructor we refer to as related to integer 1. Okay, the reference to this constructor is assigned to a my functional reference called my class constructor. Okay, so reference to this constructor, which constructor? Parameterized constructor, is assigned to my function reference called my class constructor. And then this, after this statement is executed, my class constructor can now be used to create instance of a my class or object of a my class, like my class constructor dot function 100, and it will be assigning just a value and then displaying getting that particular value as 100. Okay, my class constructor has become another way to call my class integer v. It is just a constructor reference. Okay, so instead of directly creating objects, we are creating object through my class constructor reference. Okay, constructor references to generic classes are created in the same particular fashion. The only difference is that type argument can be specified. So here there is no type specified, and in the generic classes type will be specified. This works the same as it does for using a generic class to create a method reference. Simply specify the type argument after the class name. Class name, type argument, and then double colon. Okay, now we will see by modifying the previous example so that my function and my class both are generic. Okay, so my function functional interface is now generic, and it is having the my class or creating the my class object which is also generic. Okay, so type is also not specified. Here we are directly passing the t. So t can be anything. Next, so here we are creating the value and the constructor that takes an particular argument. So argument is also t, value is equal to v. Okay, this is the parameterized constructor. Okay, and this is the default constructor, value is equal to null, then returning value. Same way. Okay, only the type specification is different. Now we will create a reference to my class t constructor. My function integer my class constructor is equal to. So here what we are creating, constructor reference. How it should be created? Only the type specification is different. This is the functional interface name, my class constructor, and how functional interface reference variable name is my class constructor. How it is created? Class name double colon new. Okay, so using this constructor we can call the function of the functional interface my function 100. Okay, and it will be relating to parameterized constructor like in the before example we have seen already. Okay, so this mc will be getting value and putting value as 100. Okay, This program produces the same output as in the previous version. Now in this case, my function and my class both are generic. So the sequence that creates a constructor reference can include a type argument. Okay, it is not always needed, but still, since it is a generic, we are passing it as here also integer and here also integer. Everything else is same. Because the type argument integer is already been specified when my class constructor is created, it can be used to create my class integer object as the next line shows. So here we are creating the my class integer object. My class integer MC is equal to my class constructor. This is the functional interface reference variable name and dot function 100. The preceding example shows the mechanics of using constructor reference. No one would use it because nothing is extra yet over here. And having what amounts to two names for the same constructor creates a confusing situation. Okay. So there can be two parameterized constructor and constructor with having the same name and same number of parameters, same type of parameter. So they can be creating the confusion. Okay. So to say the least. To give you the flavor of more practical uses, the following program uses a static method called myClassFactory. This is the factory for objects of any type of myFunction object. Now, it can be used to create any type of object that has a constructor compatible with its first parameter. Okay. So now we will see the example that uses a static method. First of all, myClassFactory. And this method is a factory for objects of any type of myFunction functional interface object. And what is the criteria? It can be used to create any type of object that has a constructor compatible with its first parameter. Okay. So R, T. So it should be returning R, T, and taking parameter as T and returning R. Simple generic class T, private T value, my class T B, and value is initialized to B. Then the default constructor having no value, null value, and get value will return a value. Now simple non-generic class, my class 2 having string as a variable and constructor that takes an argument S and string will be initialized to S. Now default constructor of this class, this constructor is not used by this program and returning value. Next, constructor reference demo 3. The factory method for class object. The class must have a constructor that takes one parameter of type T. Okay. R specifies the type of object we created. Okay. So, what is the rule? The class must have a constructor that takes one parameter, at least one parameter, and at most one parameter of type T. So T can be anything. T can be integer, T can be float, T can be double, T can be anything. And R is a type of object that is being created. Okay. My class factory, my function R T constructor T V. Okay. So here the reference variable functional interface reference variable will be passed over here as a const. It will be replaced by const, and this is the value P. Okay. And class must have a constructor that takes one parameter of type T. Okay. So here my class factory method is returning R and type is R, P, and it will be what is the function called? Constructor dot function P. So what is the function definition? Here okay. This is the function given over here. Next, my function. Create a reference to my class constructor. How to create? Class name double colon new. In this case, new refers to the constructor that takes an argument. Okay. My function, my class double. Okay. And double. So here one parameter is double, my class double, and second is double. and this is my functional reference variable name is my class constructor, and constructor reference is created like my class double colon new. Okay, create an instance of my class by use of factory method. So my class factory, we are passing here my class constructor reference variable, and double value is passing 100.1. Okay, so this object is now referring to object of class my class. So this object we will be using like this, value in MC is 100.1 like this. Now create a different class by use of my class factory. This is my functional interface, my class 2 string, my class constructor 2. This is the reference variable of the functional interface my function, and it is my class 2 double colon new. Now create an instance of the my class 2. How it is created? My class factory, first of all constructor reference, and string is lambda. Okay, so this will be the object created of my class 2, and it is displayed like this, string is MC2 is lambda. Okay, so value in MC is 100.1, string is MC2 is lambda. My class factory is used to create objects of type my class double and my class two. Both classes are still different, but my class is generic and my class 2 is not generic. But both can be created by my class factory still, because they both have constructors that are compatible with the function, the my function. Okay, so both are having the constructors. What are the constructors we have just seen? That is the type compatible with this. Taking the parameter as T, returning R. Okay. So here also taking the parameter and returning R. So this is the parameter T, returning object of class my class. Okay, and here also taking the parameter, one parameter B, it can be anything, and returning class my class. Okay, so it can be used in both ways. My class factory is passed the constructor for the object that it fits. Now we want to, you can experiment with this program a bit, trying different classes that you can create. You can create many more classes to experiment with this program. Also try creating instances or objects of different types of my class object. Okay. Now we will see, as you have seen, my class factory can create any type of object which class has constructor that is compatible with the function, with the functional interface my function. Okay, although this example is quite simple, it hints the power that constructor references bring to Java. So this is the actual example that is giving you the power of constructor references. Now we will see the second form of the constructor reference syntax. Like we can declare it like this: to create a constructor reference from an array. How to create it? Type opening and closing square bracket, double colon, and new. You can write down this syntax. To create a constructor reference for an array, use this constructor. Type opening and closing square brackets, double colon, new. Okay. Here the type specifies the type of object that is being created, assuming the form of my class is shown in the first constructor reference example, constructor reference demo, and given the my array creator interface is shown here. So my array creator is the interface, functional interface having parameter as T, type T. Okay. First constructor reference example that we have seen, constructor reference demo, and given the my array creator interface here, the output syntax can be written like this: interface my array creator T function integer n. Okay, so now this will create a 2-element array of my class object and give each element an initial value. So we are passing array of my class. Okay, class object will be in the array Then my array creator constructor reference can be created like this. So interface, this is the interface name, it's the functional interface name, my array creator. What we are passing over here is array, not a single primitive type. We are passing the array of class objects. My array constructor is equal to my class a type, that is it is having type of array. What is the type of array? My class, opening and closing square bracket colon new. This will be creating the constructor reference MC array constructor from the functional interface my array creator. So now my class type array A is equal to constructor reference dot function 2. Okay, so this is the type. This will be returning the array. Okay, this is the function name and having one parameter n. A of 0, new my class 1. Okay, and each element will be initialized like this. A of 0, new my class. Why new my class? Because array is of type class, not integer, float, double, boolean. So each value in this array will be an object of type my class. So how to create object? We create object like class my class A is equal to new my class. So it will be like this, new my class, and parameter is n. Okay, new my class 2. The call to function 2 causes 2 element array to be created. Okay, so 2 element array will be created over here, that will be having 2 elements. The functional interface must contain a method that takes a single integer parameter if it is to be used to refer an array constructor. Okay, so in generalized syntax, a functional interface must contain a method that takes a single integer parameter. Here it is taking integer n, single integer parameter, if it is to be used to refer to an array constructor, because this n will be telling you how many elements will be in the array. So it must be having the single integer parameter. Okay. Next, predefined functional interfaces. Now we have created the functional interfaces by own. Those are custom interfaces, but there are still predefined interfaces are there. Up to this point, the examples in this chapter we have seen their own functional interfaces, so that fundamental concepts behind Lambda expression and functional interfaces could be clearly illustrated. But in many cases, you won't need to define your own functional interface because they are already there. The package called java.util.function provides several predefined ones. So we will look at them more closely in part 2. Here is a sampling. So here are the methods. Functional interfaces. Unary operator T. Apply a unary operation, that is increment, decrement, to an object of type T. T can be anything, and return the result, which is also of type T. Okay. So like integer is incremented by 1, returning integer. Double is decremented by 1, double is returned. The method is called apply. Okay. Binary operator T. Apply an operation on 2 objects of type T and return the result of also type T. The method is also called apply. Consumer T. Apply an operation on object of type T. This method is called exit. Okay. Supply T. Return an object of type T is called method is called get. Function TR. Apply an operation to an object of type T and return the result as an object of type R. This method is called apply. Predicate T. Determine if an object of type T fulfills some constraint. Return a Boolean value that indicates the outcome. This method is called test. Okay. Now we will see the program that shows the functional interface in action by using it. To reverse the earlier example called block lambda that demonstrated block lambdas by implementing a factorial example. What is block lambda? More than one sentence in that using the opening and closing curly braces. That example created its own functional interface called numeric function. But the built-in function interface could have been used like this in this version. Okay, and what we did in that, use the factorial demo. Okay, Now we will see the function built-in functional interface. Import the function interface. Import java.util.function function. Okay, so class use function interface demo. Directly we are using it from this package. So this block lambda computes the factorial of an integer value. This time function is the functional interface. Okay, so function integer integer is taking two parameters, integer and integer. Factorial is equal to n. Okay, in detail result is equal to 1. What we are doing, computing the factorial. The factorial of 3 and 5 will be displayed, and it will be producing the same output as the previous versions of the program. Okay, so this way we have understood so many aspects related to lambda expression. Lambda expression is a very new technology nowadays. So what you have to do, you have to just practice it. To enjoy it, you have to just first of all practice it more, understand it very clearly. Theory should be understood very clearly. After that, practice it more and more. After that, practicing by your own, you will be understanding the power of lambda expression. And once you have understood the theory concept, practical part is not a big deal. Okay. In the next session, we will be viewing the same practical example that we have seen in PPT part. Okay, so meet you in the next session with the practical examples. Thank you so much.